All right. The next problem we're going to solve using arrays and loops is a very fundamental one, the so-called universal property versus existential property. And we actually are dealing with two related problems with 4 different versions of solution for each. So we got 8 different solutions to present. So I would say I'm going to use my iPad for the purpose of the illustration for all the 8 possible solutions. I'll try to present the flow to be as smooth as possible. However, the slides themselves, they are pretty self-contained. I would suggest after you have gone through my illustration on the iPad, it will be much easier for you to go through the slides yourself. Okay, so reading off the slide is not my style. So I'll rather leave the slide to you for your study, and then I'll just present to you to give you the idea in the iPad. But for the slides, for this video here, the relevant slide will be starting from slide 36. So when we start talking about all positive, right? And then I want you to know that starting from 36 all the way to, let me see this, all the way to slide 49. From 36 to 49. So these slides, I will be presenting the problems on the iPad instead. Okay. Another useful reference for you would be, again, let me point to the additional resources for you. For this problem specifically, when we talk about universal versus existential properties for arrays, again, it's a very fundamental pattern for solution that you should know. And I also got some extra videos over here. If you wish to explore further about how to do these problems in Eclipse, you can feel free. So these are the videos. They are part of the videos I suggested in the beginning of this week. So from 29 to 33. Okay, it's your call. All right, let me go back to the slides over here. Okay, and now I'm going to switch to my iPad to present to you what the problem is and then the solution. We got 8 of them in ultimately. All right. Okay, so we are really talking about computational problem, right? And then specifically we talk about how you can check a universal property, meaning that it is a property that should be universally true for every element in the array. For example, let's say the property that we are talking about over here, just one example, is the number should be strictly larger than 0. That's one property. So now we are saying that this element should be larger than 0. This one should be larger than 0, and etc. For every element in the array. If all the elements satisfy this property over here, we would say that universally this property is true. In that case, the result or the return value should be true. On the other hand, symmetrically, there is another category of property called existential property, which means as long as there exists one witness elements that will satisfy this property over here, we will be okay, right? So I'll just deliberately use the same property over here for illustration. Let's say the property is strictly larger than 0. And then we're saying that out of this many elements in the array, as long as one of them actually will satisfy this property here, being positive, then it will be considered that the existential property over here is actually holds on this particular array, as opposed to universal. You can think about universal property over here is like a generalization of conjunction, meaning that every operand, every element involved must be true for that property. On the other hand, for the existential quantification, it's like a generalization for disjunction, meaning that as long as one of the elements that's involved, for example, this one here, as long as one of them is that's involved, it will actually hold the property, then the existential property will hold in the entire collection. All right. That's something I would like to say first of all, right? Usually we shouldn't really talk about these two in isolation. These two are really related. So universal, think about, it's more like a generalization of conjunction. On the other hand, when we talk about existential, it's like a generalization of disjunction. Okay, vertical bar, right? For those of you who might be taking a logic course, you might know what I'm talking about. But if no, I'll try to assume nothing about the background, right? To present you the most intuitively as I can. All right, let's talk about these two properties, and then we'll try to see how we can code different versions of the solution for these two. Let's start with the universal property over here. Okay, let's say the property we want to check is, we want to know whether it is true or not that all the elements in the array that's given, for example, this array of size 5, if all the elements of the array will satisfy this property, that is positive, right? Apparently, for this case, you will see it is not, because this will be one particular witness of violation, right? You can see here, this will be one witness, we call it witness of violation, meaning that this universal property larger than 0 actually does not hold. It should be false for this particular instance, right? But how exactly do you code? Let's not worry about the loop just yet. What if I just tell you that it's going to be a fixed size of the array? In that case, what you will do is you'll simply check that element at index 0, index 1, all the way to the last index for this array of size 5, they will all be larger than 0. This will be the property that should hold on every element. And now to really make sure not only that this is the case, this is the case, and this is the case, and this is the case, and etc. So that's why we are using this conjunction over here to make sure we check the universal property over here, right? So hopefully you can see, whenever we talk about checking universal property, that's why I said it's a generalization of conjunction, because you want to make sure every element actually must satisfy that property in order to make sure the universal property is actually true. Otherwise, if any one of them happen to be false, for example, you can see element at index 2 over here is actually false. That means the entire conjunction over here would just be false, right? So hopefully you can see my point. All right, for this one specifically, you can see at index 2, that one there is really -1, right? So you can see this one here is actually false, meaning that the total result is actually going to be false. All right, for this particular example. And we may just declare a Boolean variable called all positive, and then you will record this value and then eventually return it or print it. All right, that's about universal property. And I would like to mention two more properties about logic, right? Which I didn't speak about before, but it will be handy for later. Okay, one is called number 1, the 0 of conjunction. Okay, that's property number 1. Okay, logical property. That one's easy. If you actually get false conjoined with any Boolean variable b, it would just be equivalent to false. This one's easy, right? Remember we talked about the only way to make conjunction true is when both sides are actually true. But if one side is already false, the result must be false no matter what, right? That's the 0 of conjunction. I'll speak about the symmetric one for disjunction as well. Another one is called the identity of conjunction. Identity of conjunction. This is also very important because when we talk about what the initial value should be, the initialized value should be for the Boolean variable, we should consider this. Identity of conjunction is something like this, where we have true and some Boolean value, some Boolean variable b, right? What would that be? Given that the one side is actually true, for the other side, we don't really know what the result is for the conjunction just yet. It really determined by the b. So this will just be equivalent to b. Okay, if b happens to be true, the entire conjunction will just be true because true and true will be true. If b happens to be false, that will be true and false. In that case, the entire result will be false, right? So these are the two extra properties I would like you to keep in mind, right? These two are also important. Okay, so that's about universal property, right? And our discussion for existential property will be very symmetric. Okay, so let's say I declare some variable over here, at least one positive. At least one number is positive, which means either this element holds this property or this, or this, or this, or this. As long as one element, at least one element in the array actually holds the property, in this case larger than 0, then the existential property would be held. Okay. In this case, you can see this particular value over here in the middle. I call this the witness of satisfaction, kind of symmetric to witness of violation in the case of a universal property, right? So this will be witness of satisfaction, meaning that it's a witness in which we can say that there's at least one element in the array that will satisfy this property because that's larger than 0. Okay, and then you can see we are trying to check the property over here larger than 0 for every element in the array. For index 0, 1, 2, 3, 4. In general, you can think about it's really from 0 until ns.length minus 1. Right? That's something we can do. Definitely use a loop, but I'll get to the loop in a moment. And then the way we do that is by really using here the disjunction over here. Right? Disjunction is to say either this is true, or this is true, or this is true. As long as one of them is true, disjunction will be true overall. Right? In this case specifically, you can see this element at index 2 is actually 1. So 1 larger than 0 is going to be true. So this will actually make it true. Okay, so this one, let me just see what I did over there. Yeah, exactly. This will be true. So this is going to be true in this case, right? 1 larger than 0. So the entire disjunction will be true for sure, despite if there might be some false value for other elements. So now, symmetrically, I would like to mention 2 logical property. Remember, I talked about 0 of conjunction, identity of conjunction. I will also mention about 0 of disjunction and identity of disjunction as well for completeness. Let me do that. 0 of disjunction. All right. So vertical bar is disjunction. So that is to say, if I know one of the operand is already true, and then I got some Boolean variable b, so that will be just true. Remember we said before, the only way to make a disjunction false is when both operands are actually false. If I know that one of them is already true, the other one doesn't really matter. It will just be true. So that's the 0 of disjunction, right? We actually talked about this already. So in some way, it's not really something new. What about the identity of disjunction? Identity of disjunction over here, right? So now it's going to be false. Or b is equivalent to just b, right? This is to say, if one of the operand for the disjunction is already false, the overall result for disjunction really depends on b. If b happens to be true, in that case, true or false is going to be true. So that's exactly b. If b happens to be false, in that case, false or false is going to be false, which is also equal to b, right? So that's the identity for disjunction. All right. So that's about a very quick summary, intuitive summary about what we are really doing for universal as opposed to existential property. Please understand the intuition, and then this particular property about identity for conjunction, in which case we're going to get true. True is the identity for conjunction, and also false is the identity for disjunction, right? In that case, we're going to see exactly how we can code it up. I would like to mention one more thing. Okay, you can see now we know exactly what the size of the array is. That's why we can simply write it out, this particular long expression. But what if we don't actually have the definite size of the array? We simply got ns.length. That's all we got. So ns.length can be 5, can be 100, can be 1000, can be very large. In that case, how can we do? You can think about in some way, we have to go for element by element for each iteration. For the very first iteration, we can determine if this is true. For the second iteration, we can determine if this is true. And for the third iteration, we can determine if this is true. All the way to the last iteration, we're going to determine if the last element will hold this particular property. And similarly, for this, the existential property. However, what should be the initial value for this versus the initial value for this? So that'll be the question, right? We're going to see that in the versions that we're going to speak about. All right, that's enough about intuition. So now I would like to move on to the 4 versions of code that will attempt to implement universal property checking, and also another 4 versions for existential property checking. We're going to talk about side by side to really make a contrast right away for you. All right, so version number 1. So let's say we talk about how we check for universal property. All the numbers positive in a given array. Let's say here ns, it could be some parameter for your utility method, but for now, for simplicity, let's say it's simply initializing this way. It's simply 2, 3, -1, 4, and 5, right? Exactly this array is visualized over here. Okay, let's see exactly how we implement the first version. The first version, I can tell you it is correct. Let's go over this one in detail. Once you understand the first version, all the subsequent 3 versions will be much easier to understand. Also, I'm going to go over the trace table together with you. That's also available on the slides. I'll guide you through completely. Don't worry. Okay, so we will see that number 1, you can see we got some Boolean variable over here. So far, only positive numbers. I want to be as informative as possible for the Boolean variable. Okay, let's say this Boolean variable, so far only positive numbers, tells me whether so far the numbers I have read so far from the array have been positive only. As soon as this, if there's any negative number that's being read in the array, for example, as soon as I get to over here, I'm going to set this value here to be false. But initially, it's simply just going to be true. And I'm going to explain to you why initializing this variable to be false will be wrong when you want to check for universal property. But let me just mention something here. Remember previously we talked about this is the identity of conjunction. Conjunction, meaning that if you simply got true on as one of the operand, it's not going to impact the right hand side of the operand, right? If you make it false, it's going to be the 0 of conjunction, which will make the entire conjunction to be false anyway, despite other operands. All right. And then for the rest of the loop, let's now see something that that'll be quite trivial for you. Okay, let me tell you the standard one. It's going to be I initialized to be 0. I'm using a while loop, so that will be the loop counter. And also state condition will be is going to be strictly less than the length of the array, and also increment each time. So once you have seen this, let's see. Let's now annotate the tracing table right away. For the value of I, we know that it's going to be 0, 1, 2, 3, 4, and then as soon as you get to 5 over here, for the 6 at the end of the 6th iteration. Beg your pardon. At the end of the 5th iteration, it's going to increment the loop counter from 4 to 5. In that case, it's going to make the state condition over here false. And then, so that means we're going to not state, we're going to exit from the loop, right? Everything before is simply just going to be true, as we said before. And then, so that means we're going to stay for 1, 2, 3, 4, 5 iterations, right? So far, I'm just explaining bit by bit to make sure you understand. And then for every iteration, we're also going to find out what the elements, what the current elements is. So now, for example, for the first iteration, I will be 0. So that means n is 0 will be 2. And then 3 minus 1, 4, and 5. So 3 minus 1, 4, and 5. Right? So far, so good. Now, the question is this. How do we actually check to see that we want to say ultimately we want to know whether every element or all elements in the array given actually satisfy the property larger than 0, right? So what we will do is, so this is the part I would like to highlight. So this is the line. Okay, let's see what we're doing over here. We are saying that this so far only positive numbers initialized to be true for every iteration is going to accumulate by itself conjoined with whether the current elements is strictly larger than 0. That's basically what we're doing, right? Okay, let's try to trace this part. It's really important. Okay, let's now try to do this. For the very first iteration, I will be equal to 0. In that case, the current value for so far only positive numbers is simply the initial value, which will be true. So that'll be true, and also we know that n is 0 will be 2, and then true and true, basically. True and true, right? True is positive. True and true is going to give you true. So that means the updated value for so far only positive number from the first iteration is going to be true. So that's why you see true over here. All right, hopefully you're okay so far. And then let's see the second iteration. For the second iteration, we're still going to execute this particular assignments. So it's going to accumulate itself conjoined with the second elements, right? It's going to be basically itself will be true, and also 3 over here, 3 larger than 0 is also going to be true, right? The value is going to be true as well. So that's why you get true to start with for the third iteration, right? So this will go on. Okay, so let's see whether there will be any element that's going to make the whole thing false, right? It will be. Let's see the third iteration. For the third iteration, I is going to be 2. So that means we're looking at this particular element over here. So far from the previous iteration, so far is simply just true. So we got true over here, and now the current element -1. -1 larger than 0 is going to be false. So now true and false is going to be false. So once we get false, you can see from now on, the so far only positive numbers is going to remain false no matter what. Remember the 0 of conjunction. If you remember the 0 of conjunction over here, so as long as one of the operands is actually false, it doesn't matter what this is. You can think about this part here is already so far positive numbers, right? That's already false. And doesn't matter what the current element larger than 0 or not, because it's going to be false anyway. All right. You can see once we get to this part over here, you will see that the so far only positive number will just remain false all the way to the end. That's really important for you to see. All right. So so the important point would be once we get after the third iteration where we actually got false for this particular element, which is -1. That's the witness of violation. Once we get that, we're going to accumulate false into the conjunction. So it's going to be false throughout. Okay, so there's no way for us to continue. Let me give you a little bit of look ahead. Having seen this, is it possible, is it really necessary once we see the very first false over here? So that means there's no way for the universal property over here to be true eventually. It's going to be false for sure. Is it possible to say we exit from the loop right away? Is it possible? That can actually save quite a bit of iterations. Imagine that if you got a very, very long array over here, and then as soon as you see the very first negative number, let's say -1, after this, we know that the universal property is going to be false anyway. So it's really no need to relook at the rest of the array. But it's not the first version. The first version may be inefficient, but it's correct. All right. That's for the first version. All right. I think one more thing I want to say. You might be wondering about this part over here. We say that this is true. Okay, so we want to ask yourself this question here. What if it was set to be false? What if, right? The question, the answer is very obvious. If you simply set this initial value to be false, it's going to be completely wrong. Because, hypothetically, if you set it to be false, right? So that means when you start the first iteration, rather than true, it's going to be false to start with. And then, does it really matter if the current element larger than 0 is true or not? Does it really matter? No, it doesn't matter, because if you already got false as one of the operands for conjunction, this part here doesn't matter. It will just be false. That's exactly what the 0 of conjunction property is really talking about. So if you do false, no, because in this case, NSI larger than 0 check is meaningless. Okay, and that's to do with the 0 of conjunction. All right, guys. I hope that makes sense to you. So that will be the first version for the checking the universal quantification. The universal property. Okay. What about the symmetric one? Let's talk about version number 1, also for solving the existential property. Okay, over here. Let's say the problem is we want to know whether it is true or not that at least one number in the array is actually positive, at least one. So this is the existential problem that we are trying to solve, right? So now let's see the symmetry over here. Number 1, you're going to see that here we got a variable here. I simply name it as seeing some positive number. Have we seen so far any positive number? As soon as we have seen some positive number, we're going to set it to be true. But to begin with, we're going to set it to be false. And let me remind you, the false over here is actually the identity of disjunction. Identity of disjunction, right? You can now think about what if that's true. If that's true, that means according to the 0 of disjunction, true or anything will always be just true, despite what something is, right? Okay, so let's go on, and then we're gonna say for every and then let's see what's really standard. Loop counter will be 0 and also strictly less than length and also +1. So that means we're gonna have 0, 1, 2, 3, 4. Okay, we're gonna have 5 iterations, and then we're gonna stay for 5 times. And also you can see these will be just true. Okay, similar as before. I don't need to waste your time. And then the elements would just be over here, -2, -3, 1, -4, -5, exactly over here. Okay, let's now watch what's going to happen here. So what's going to happen is this. You can see initially this is simply just false, right? It's false. So that means we'll start with false over here. So that will be the identity for disjunction. And let's say for the first iteration. For the first iteration, we're going to execute this line over here, which is going to be the seeing some positive number accumulated with itself. Initial value is simply just false over here. So that'll be false. Or what's the first number? The first number is simply -2. -2 larger than 0 is false. Okay, so that will simply just be false. Okay, so this will be false, and then false. So false is going to be false. So which means starting from the second iteration, the seeing some number, positive number, is still going to be false. That's what we're going to start with. Let's say for the second iteration, okay, let me use green. And so now the element I value we talk about is 1. So that means we're talking about this particular value, so which is -3. So currently it's still false to begin with, or -3 larger than 0 is actually false. So we still get false, meaning that at the end of the second iteration, this evaluation will still be false, right? You can see we keep using disjunction over here. Okay, let's go a little bit further. What about the third iteration? For the third iteration, I is going to be 2. Looking at index 2, we got 1 here. So 1 larger than 0 is going to be true. So that means we got false, the accumulated value so far, or NSI larger than 0, which is true, because we got 1 larger than 0 is true. So now remember, this is the 0 of disjunction. So this will give you true. All right. So now it's really important to see. Once we get to this point that this is true, let me use a different color, right? So once we get to this point that this is actually true, so that means you can see seeing some positive number will never get back to false again. It will just remain to be true, right? Once because of the 0 of the disjunction. Remember the 0 of disjunction. So if you got true already as one of the operand for disjunction, doesn't matter what the other one is, it will just be true. Okay, so that's the 0 of disjunction. All right, so it might be another scope of improvement. As soon as we see some value, like a witness, that will satisfy the property, is it possible to exit from the loop right here? Is it possible? Because the result for the existential property checking will be true anyway, right? It's going to be true no matter what over here. Right, so it's similar to once you get to the false for the universal property, is it possible to exit from the loop at this point over here? Similar idea. All right, so you can see version 1. That's why I want to talk about these two side by side, so you can really see exactly how things should be solved accordingly. All right, so if you go on, we can still check to see the rest. You can see -5, -4, -5. Even though they are false, it doesn't matter because this value over here is already true. So you basically get true or false, right? True here is the value for this accumulated variable over here, and the false is the current element being negative. That'll be false, right? But it will still be just true. Doesn't matter, right? Because we have seen 1 already. All right, so that's about the version 1 for both. So I will encourage you to really contrast these two before we move on, right? Let me say it again. So for the universal property, you got to initialize to be true and accumulate using conjunction. Okay, and then as soon as one of them is going to make it false, it's going to be false from then on. In which case, we may have another version to really to improve, to maybe have some early exit for the loop. Right, we'll see that in version number 3 and 4. Okay. And then for existential property here, initialize the Boolean variable to be false, and then we're going to accumulate that variable using disjunction throughout. As soon as one of the witness will actually get to true, so that means the accumulated variable is going to be true from then on. in which case we might just exit if we want early exit. All right, so now let's move on to version number 2.